And the tweet. Okay. Yeah. Yeah. And the Meetup app new Michael Hart was coming as well. Michael was actually a former serverless hero. Or were you a community hero? You serverless hero, yeah. But now, now he OG exactly. Well, you're now a cloud player, so kind of a competitor. But maybe you'll grace us with the talk at some stage. I'm putting you on the spot now, but talk next month. Excellent. But for now, shameless, I know, I'm terrible. But for now, I want to welcome our first speaker, Bappi. He actually flew from Sydney half an hour ago just for this meetup to give a presentation. So I just want to, it's amazing. And he's not even staying, he's flying back right after the talk. So he literally made the trip to give this talk, and then he's flying back. So like, I am touched. I'm genuinely touched. It's amazing. So we are going to hear a lot of cool stuff about building SaaS on AWS using serverless. All right, Bappi, over to you.
Thank you. Thank you. All right. So as Peter said, my name is Bappi. I work in AWS in a team called SaaS Factory. Our primary job is to help partners and customers build better SaaS. The way we do that is discover new patterns and practices and share it with them. That's it. We don't write production codes. And we would like to share our knowledge, whatever we have learned. So we like to share what we have learned so far in many different forms, like writing blog posts, creating videos, or speaking into the user group is one of them. Hence, I'm here. Right. So before we start, I think we should start with a simple definition of SaaS. I know you all know what SaaS is and you have your own definition of SaaS. All of them are correct, but this is how we view them. The SaaS is basically a business and software delivery model. And it offers you to provide the solution in a low friction and service-centric approach at a scale. That's the important part. And to do that, you will definitely need agility and operational efficiency to provide it the growth it needs, the reach it needs, and the innovation you can offer in your services. That's it. I won't bore you with any more definition. That's the end of it. Now, so to build a good SaaS, since we have been building it so far, there must be a blueprint, an architecture that I can give you, and you can just start building a good SaaS or the best possible SaaS. Unfortunately, that's not the case, because building a good SaaS depends on your business demands, depends on what your customer wants, depends on what your focus is, whether it's growth or cost effectiveness. A lot of things needs to be considered. But what we can give you is a blueprint that you can follow for every single project. So without further ado, let's get into the blueprint. So in SaaS, first you have a concept of tenant. Anyone here understand what a tenant is in a multi-tenant SaaS environment? Not you, Michael. Not you too. Yes, please.
Tenant is like a isolated environment for a single operation. Not operation, set of different your business projection. I would say isolated projection of whatever you are offering or SaaS, probably.
Yes, that's a good view. Anyone else with a different view? Yes, please.
Could be a customer, which could be a company or a user, or
depending on the scenario. Yeah, that's the simplest description. Thank you. All of them are correct. Yes, tenant is, you can think of it either a set of user or a customer or a company just isolated for some reason. Think of an example like you are offering, let's say, payroll management service as a SaaS offering. And one company signs up for it, they are a tenant. Another company signs up for it, they are another tenant. So tenants are, easiest way to think about them is a company. Now, in the blueprint, you have tenant. The first thing you need to consider is how do you authenticate the tenants and their users? And how do you onboard them in your system? After that, you can think about developing your application services. It can be microservices, it can be monolith, it really doesn't matter. Oh, sorry, it has to be serverless. I forgot I'm in a serverless meetup. So yeah, it really doesn't matter what your technology is, but your application services lives there. Underneath that, you would have storage, different partitioning scheme, and whatnot. But what is important is in your application and storage, the concept of tenant isolation will be baked in. Tenant isolation is exactly what he mentioned. They have to be isolated either logically or physically so that one cannot access someone else's resource. This is one of the single most important concept in a SaaS application, tenant isolation. We'll dive a little bit deeper on that later. Other than that, you'll have to have metrics and analytics collected from the system so that you know what's happening, which part is hampering, which part needs attention, which part needs upgrade, all of that. Billing and metering, you are definitely not providing your service for free. So you need visibility of cost, like which system is costing you how much, and how should you bill your customers. All of them is a responsibility of a well-architected SaaS system. And you also need to have the deployment automation. The reason being, agility is one of the key aspects of SaaS. You need to be able to frequently deploy updates and experiment and then roll back. If you don't have deployment automation, that just doesn't become possible with the manual approach. Other than that, management and monitoring, which is managing and onboarding new tenants, migrating their tiers, releasing new services, monitoring your entire system's health as well as tenants' health is part of the responsibility of SaaS. Now, if you think about all of that and you start building your application, it can become overwhelming pretty soon. So that's why we separate the concepts. Like we call something an application plane, which is the application that you develop, which does not really need to think too much about SaaS. But the other responsibilities that I've mentioned is a responsibility of control plane. So we define the concept of control plane with three primary responsibilities. One, it should provide you a single pane of glass, like through which you can look at systems health, tenants health, other metrics like onboarding time, which one is failing, what is the reason of the failing. Everything should be centralized and you can look through a glass. It should provide you the operational support necessary to onboard a new tenant and let's say, what are the error rates that are failing, and also how do you migrate one tenant, user management, tier management, all of those should come as a part of operational support. And it should also provide you the orchestration tooling needed for complex multi-step processes. For example, onboarding a tenant may require creating database entries, creating infrastructure, and then tying them together. It's a complex multi-step process that may take several minutes, and it should provide you the tooling. Other complex processes can be setting up billing systems and integrating them, maybe making a test payment to make sure that they're active and they're valid, all sort of things. So this should be the responsibility of SaaS control plane. When we talk about building a SaaS application, we generally mean building a really good control plane that can support your application plane in doing good SaaS. Is that distinction clear? Okay. Now we can move forward and start diving deeper and deeper. I mentioned tenant isolation as one of the single most important concept in multi-tenant system. What is tenant isolation? I explained briefly, but let's look at it pictorially. So the tenant isolation can be thought of as a partition between two tenants. They're partition between resources. One way of achieving that is through siloed infrastructure or completely separate infrastructure. Think of it as separate AWS account per customer. That's the best kind of isolation. Nothing's being shared. Another way can be VPC per tenant. Again, complete separation, no sharing between them. The problem with that is it's not scalable. So if you keep onboarding new customers, your cost would grow linearly. You're not really getting any benefits from the SaaS offering. Your cost should become stagnant at some point if you have a lot more customer coming up. So on the other extreme, we have a completely shared model where it doesn't matter how many customers you have, they will all be sharing the same resources, like same database, same compute engine, or whatever you are using for your SaaS offering. This is known as the pooled model. Now, you don't have to choose one or the other. You can choose both of them depending on service and compliance requirement. For example, if you have highly sensitive data that needs to be physically separate, you just put that part of the service in the isolated system, but rest of the things like web application, you can use a pooled model. So this is known as a hybrid or bridge model. So yeah, I just wanted to clarify the difference between silo and pool model, because we'll be talking about pool model now. Silo model, pretty straightforward. You just keep them separate. There's no complexity around that. Pool model, however, gives you the benefit of cost efficiency. As I said, your cost would become stagnant at some point, and it will not grow linearly. That's the sweet spot to be in when you're offering SaaS. Now, what could be the challenges for a pooled model compared to siloed model, and how can we solve them through serverless infrastructure? Let's look at that. So consider that you have a service offering that requires DynamoDB. For example, your requests are coming from different tenants and they're hitting, pardon the EKS, think of it as Lambda. They're coming into your workload, and depending on the type of the request, let's say you're making a request for order, which I have separated into two separate tables. Now, this is an example of siloed model. I have, for tenant 1, I have one table, and for tenant 2, I have another table. So if a request comes for order, your services know which table to go to. That should be easy for you experienced developers to figure out which table to go to for which customer. However, on the product table, it's shared between all of the customers. So if any request comes for product, both of them will go to the table. Now, the challenge here is to make sure that customer 1 or tenant 1 cannot really access the data for tenant 2. Easy way to do that is to add a hard-coded where clause in your query whenever you're doing it. But we as a developer tend to have bugs in our code, and that's not uncommon. But if you have such bugs where you forgot to add a where clause, consequences could be severe. Like you can expose some very sensitive data to someone inadvertently, and you may be facing lawsuits and other worst possible actions. So we need another level of defense, which is from the infrastructure level, where even if you forgot to add a where clause in your query, AWS would say, or any same cloud provider would say, no, you do not have permission to access this data. Let's have a look at how do we achieve that. So in the silo model, it's pretty easy. You just add DynamoDB permission to a particular table and assume a role that has this policy statement. That way, you are only restricted to access one particular table. So that's through IAM policies. Now, in the pooled model, it's very similar, but if you see that there's a new thing called condition. This condition is, are any of you familiar with the leading keys condition in DynamoDB? You, I know. Okay. So what it says is if you have a partition key and there should be a value which must match with a particular value. Look at this table, the pooled table, the product table. The first key is the partition key, and it has the IDs of tenants, tenant 1, tenant 2. Now, this policy here is saying if the value tenant ID matches the currently logged in user's tenant ID, which is tenant 1, you are only allowed to access those rows in this table. And that's how we are preventing inadvertent access to the table. Okay. So this is one example of storage tenant isolation. Now, we have done that. How do we make sure that we are assuming the correct role? How do we make sure that Lambda is trying to do the proper thing? So there can be many different ways of doing that. One of the simplest way or most popular way or common way that we have seen in practice is through runtime acquired tenant scope. What it means in simple terms is when a request to Lambda comes in from any tenant, we identify which tenant is the request for. It can be done through the JWT or the token that's coming in. It can have an identifier or custom claim saying tenant ID equals tenant 1. So we identify that tenant, we generate a runtime policy based on the tenant ID, and then we assume that role with the runtime policy. And then we try to access the DynamoDB or any other storage mechanism that you may have. That way, Lambda is at any given time, one Lambda function instance is running for one tenant only, for that particular request, it can only access rows that are dedicated for that particular tenant. So that's how we're ensuring your compute layer is communicating with the database in the correct way. Even if you mess up the code, forgot to add the logic, it will not access any data that it's not intended to do. Any questions so far? Either I'm explaining it really well or not at all. Yes.
Yeah, what's your recommendation for mapping the tenants to the runtime acquired tenant scope?
We don't really keep a mapping. So the policies that you saw in earlier slides, think of them as a placeholder where the tenant IDs and they get filled up at runtime. All right. So the concept I'm explaining here today is normally delivered in half a day or a day-long workshop over 5 to 6 days. I'm doing it in 30 minutes. So it may seem a bit rushed and I'm skipping a lot of steps in between. Yes.
What other services AWS support at the moment that supports this tenant isolation?
Let's see if I can say, is this recorded? No. No, so none. We don't have any service that is multi-tenancy aware. So it is our job, SaaS Factory's job, to find out which service can we use in a multi-tenanted way using their features. It may be hidden features, it may be publicly available features. If not, what are the workarounds that we can use that would still provide similar guarantees at infrastructure? That's what we do on a day-to-day basis. A new service comes up, we do research on how to do multi-tenancy using that if there's a need in the customer segment.
So, for example, in case of, let's say, RDS, right?
Yeah.
Postgres, how would you or your team implement?
You know, I had the Postgres slide, I deleted it, but I'll give you the answer. So Postgres has a feature called row level security, RLS. We can use the similar concept at DynamoDB, have a column, and then create connection per tenant. And in that connection, we can tell if the connection's ID and the tenant ID matches with the column's value, then you have access to that row. It's very similar. Yes.
In that example, we're dealing with Lambda in an RDS environment. Generally, the advice is to use something like RDS proxy from. How does that behave in that environment, that particular scenario with the policy feeds?
So even if you are using RDS proxies, Lambda would assume the role of where it has access to, right? Yeah. So in this case, the Lambda's runtime would have the assumed role of the dynamically generated proxy. So any calls going forward from the Lambda would see that you have permission to do this and that. So it really doesn't matter which resource you're accessing to. All right. So I was told that our audience is from an advanced background. So I have included one advanced topics here, which is noisy neighbors. Who here knows noisy neighbors? Sorry, let me rephrase that. Who here knows about noisy neighbor in terms of SaaS environment? Yes, someone.
Oh, so I was actually thinking about this before. I thought so with the Dynamo tables, some are per customer, so it's not really a big problem in terms of like how much throughput you want to provision. And if one customer goes really nuts, then yeah, they might hit that limit, or you could go serverless. But with the product tables, the one that was shared between customers, even with those security rules, you've got a certain amount of provision throughput for reads.
Yeah.
So if one customer goes nuts and uses some of those reads, then would that impact the other customers?
Absolutely. That is a good example of noisy neighbors. Other examples can be API gateway has some limits and your one customer is like making requests on an automated fashion and other customers are suffering from that. That's a good example. So yes, noisy neighbor is exactly that. You are using a shared application resources among all of the tenants. Again, I'm talking about the full model. In the siloed model, there is no noisy neighbor because you live in your region alone. There's no one to make noise. So when you're using pooled model and shared application resources, some of the tenants may put so heavy load on your system that others might get denied service or very reduced SLA or very bad experience of the service. However you want to define it, we just define it as noise. Because of the noise, others cannot live peacefully in the shared ecosystem.
But you
So-
can implement throttling.
We can, that is one way, but you can do it only up to certain level. What's after that?
I mean, Lambda, if there's a Lambda, sorry to cut you off. But
No, that's fine.
if there's a Lambda you're using, the throttling will prevent of doing this.
So Lambda itself does not have throttling, but it has a concept of provision throughput, like how many instances can run at any given time. That you can configure.
But that's not like tenant-based.
That's not tenant based. That's again another concept that we will not cover today called tier. You can have different tiers, like standard tier would have 250 concurrent requests. Premium tier can have all unreserves, things like that. All right, yes, but that essentially would go into a noisy neighbor situation. We have to prevent that before it hits Lambda. And I'm assuming your Lambdas are not publicly exposed. It's coming through some API gateway or some sort of thing. Okay, so this is the noisy neighbor problem. Someone is so noisy that others are being affected. How do we prevent that? I will try to give you some pointers from different perspectives. The first one is incoming request. I'm assuming it comes from an API gateway. So here's a user making a request to Amazon API gateway, and in order to access some resources within VPC or any resources for that matter. The important part is it's coming through an API gateway. Now, what do we do first? The free thing available for you without any configuration is the Web Application Firewall, or WAF. It will protect you against known vulnerabilities and DDoS attacks, etc. But that's not what we are here to learn today. What we can do is use a Lambda authorizer. Lambda authorizer is something we'll be using anyway for a SaaS environment to figure out which tenant is the request coming from. And in response, what the Lambda authorizer does is takes the JWT or JSON Web Token in your payload. It extracts the necessary information and returns an IAM policy that the API gateway would pass along to other resources. Now, in addition to the IAM policy, the Lambda authorizer also can return something called usage plan. So usage plan defines some sort of quota. That, okay, for this particular user or tenant, this is the defined quota. This is like when I'm talking about quota for API gateway, that means number of requests per minute, per day, per week, etc. And what's the burst limit for that? These are known as quota. To give you an example of quota, this can be a quota for usage plan. Let's say I've defined multiple plans, plan 1, 2, 3, 4, 5, 6, 7, for all the 8 tenants I have in my system. But not all of them are very different. If you see carefully, there are only 4 different types of plan: standard, gold, platinum, and enterprise. And they have the same values, like throttle requests per second and quota per day. Okay, so this is what I would call a tier. How many tiers I have, or you can call it a plan template, whichever you like. The concept is these are the 4 type of usage plan I would have in my system for my example, for the 8 different tenants. Okay, so this is something you have to figure out from your business. What is my customer's portfolio, not portfolio, customer profile look like? What are their usage pattern? How much are we charging them? So what should be their quota? You have to come up with this. Once you have come up with this, let's say we have a mapping here for each tenant. Somewhere in the database, it may be DynamoDB or MemoryDB for Redis, whichever you like. It's stored somewhere. Let's keep it on the side, and let's say now a tenant is being onboarded into our system. Now, we have an action here called create usage plan. Whenever a tenant is onboarding, the input to this process would be tenant ID and which tier they are onboarding. Remember, tier is the template for the usage plan, like which usage plan we should connect them to. If you forgot already, here's the tiers. standard, gold, platinum, and enterprise. They're basically a template for usage plan. Okay, so when a tenant is being onboarded, we have input as tenant ID and the tier. And the knowledge we have is tier specific plan template, like what is the quota defined for this particular tier. What we do then, we call API gateway to say, create a plan for this particular tenant. Then store it into the database that we have for all the tenants. Then what we do is when a user request is coming in, we just use the Lambda authorizer, and the Lambda authorizer makes a query into that storage. And based on what we find there, we either return the response or return HTTP 429. Pop-up quiz, what's HTTP 429? Too many requests, thank you. Okay, so this is how you do throttling on incoming requests per tenant. Any questions? Yes.
So you're creating a usage plan per tenant instead of a usage plan per tier, and then creating API keys per tenant?
API key is another way. You can do it that way too, but they would work out pretty much the same. Yes,
Did you say that in this solution, the Lambda authorizer is the single point of failure?
it is. If Lambda is unavailable, it will fail, but you would have bigger concerns to think about.
And if you want something to file, probably that, which is.
Yes.
Yeah, the good thing about Lambda authorizer is you can cache response for a really long time, let's say 5 minutes, 20 minutes. And if your payload does not change, when I say payload, I mean the JWT payload, which has your credentials, you can cache the authorization response. So it's not like it will be hitting the Lambda every time and going to the database every time. It will only go when the cache invalidates. So it is safe to say for one user, you can query like once in every 5 minutes. Now, I think I'm running out of time. I'll move a little bit quickly. So this is a little bit more advanced. Message queues. When you have, I'm sure you know message queues, SQS, and that I promise is serverless. You have used message queues with Lambda. If you're using Lambda, you are most probably using message queues. So what is a message queue? Some sort of producers, I don't care who that is, puts a message into the queue, and there are some sort of consumers on the other end, and they process the messages. It's as simple as that. So what's the problem with this? How can noisy neighbor situation arise? Remember, noisy neighbor situation is someone is so noisy that others are being impacted. If they themselves are impacted, I don't care, because you're the one making noise. I don't care if you are impacted. You will get your SLA. But I have to care if others are not getting their SLA. That's the whole point of noisy neighbor dealing. So that's how the problem becomes apparent for noisy neighbors. So imagine all of the pink messages are from the noisy tenant. And there is one message at the end of everything, which is a tenant I promise, hey, your message will be processed within 10 milliseconds. Now, it would take about a few weeks to process their message because there's a lot of noisy messages to go through. And you cannot promise an SLA because you cannot guarantee what would happen. So this is a noisy neighbor situation in message queues or SQS. How do we deal with that? We do some sort of partitioning. So producer produces message, it goes into a queue, and what we do is immediately forward it to a distributor Lambda. And the distributor Lambda puts messages into multiple queues. I have drawn 3 queues. You can do as many as you want. And each of those queues will have consumers. Now, how do you distribute? A very simple logic can be just take a remainder of tenant ID, and if it's 0, put it on the first one, put it on the 2, and 2, put it on the third one. It's as simple as that. Problem with that approach is you cannot change it dynamically. And so what do? You put it in a tenant and queue mapping table, very similar to the previous concept. And whenever a tenant onboards, you just decide based on your logic that you have decided which queue this messages for this particular tenant should go to. And the distributor Lambda would read from this table, and whenever a message comes, it will inspect which tenant it is for and put it in that particular queue. So far, so good. Still, the noisy neighbor situation can arise. Let's say you have put tenant 1 and tenant 4 in the first queue. and tenant 1 becomes very noisy, and tenant 4 would not get any response. So how do you do that runtime, deciding what is happening into my system based on system's behavior? You definitely need some sort of notification. So you get help notification and the message, whatever is going through distributor into an Amazon SNS topic. Like, okay, message for which tenant is going through. Just push that. What can you do with this information? You can have a rebalancer lambda that would look for what are the incoming messages through the distributor, and it can easily decide based on the metrics that are available for the queues that, okay, tenant 4 is being hampered in a noisy neighbor situation. So I should change the tenant 4 into a queue that is not so busy. And that's how it do that. Yes.
At what scale would you recommend doing something like this? Because I know you can pump SQS with messages all day, and if you hook it up with, you know, a lot of lambdas, it's going to chew through them very quickly.
Yeah. So it does look like a bit over engineering, but there will be a need for that when you have, like, let's say hundreds of thousands of tenants onboarded into your system and your system is message driven. Yes.
So far, you discussed the partitioning in both of the problems, right? But partitioning is itself horizontal scaling, right? Not vertical? Or maybe I'm not.
Vertical scaling would mean just increasing the resources. We are doing both here. We can increase the number of queues.
Yeah.
We can also decide a different partitioning logic based on the matrix and the notifications available from the distributor. Now, this can be okay, but as you say, it's all partitioning. But how can we increase it? Well, there's nothing stopping you to create another one from the rebalancer lambda. You have a lambda that knows that my system is hampering. What do? I create another queue and add more consumers to that. It looks a bit over engineering, to be honest. And when I implemented this, it felt like 1-2. It was too complicated to explain, too complicated to code, and a lot of testing needed. There's an easier way of doing that, which is with FIFO queues. Anyone know about FIFO queue? Yes, that's the FIFO. That's what FIFO means. But FIFO queue, same thing. First message in would be the first message to go out. What would happen if you have producers and multiple consumers in a FIFO queue? Do you know there's a special property in FIFO queue messages called message group ID? If you have multiple consumers, one message from a particular message group would be available to one consumers. But if there's another idle consumers, it will never get a message from the same message group. It may get a message from a different message group. Now think of those message group IDs as tenant ID. That means if you have 10 separate consumers, you can process 10 different tenants' messages in parallel. That's the sort of guarantee. And the FIFO queue handles the noisy neighbor situation itself. Right? It's as simple as that. But again, it can still bring the noisy neighbor problem if you have too many tenants. You cannot just keep adding consumers. You need to have some sort of distribution logic. It's very simple. So you have a simple queue which does not know anything. It has a distributor, looks at the messages, looks at the tenant ID, and distribute it to its FIFO queue. It can be a simple logic as like a divided by 3, the tenant ID, and distribute there. Or it can be another table-based mapping. So that way you can provide preferential treatment to your customers. It sounds bad, but it is actually a business requirement. An enterprise customer may want their messages processed immediately, whereas people onboarded into a shared model or paying, let's say, less premium, they would be happy with a little bit of delay. So you can have a FIFO queue for enterprise customers, put all the messages there, and have, let's say, 100 consumers. But for all of the shared level users, or let's say freemium users, you can have one queue and with like 2 or 3 consumers. That's how you provide preferential treatment to your customers. And that's not a bad thing. That's actually a business requirement when you get into the SaaS business. So I promise we're almost done. Things that are not covered, a lot of things I could not cover in 30 minutes.
Come back next month.
Yeah, we'll cover some other time when you all fly back to Sydney. So things like SaaS identity, tenant onboarding, isolation models, and a lot of things we haven't covered. We just don't have enough time. So for you, these are the resources. SaaS Lens is a white paper or a document available in HTML format. It explains everything I talked about and everything I did not talk about related to SaaS. It's a pleasure reading on your way back home. SaaS on AWS is the landing page for everything related to SaaS. You can find all of the SaaS Factory resources that we have developed, case studies, workshop, videos, tutorials, and everything. And you can find customer success stories as well to get inspired. Okay, they have become successful in SaaS. Now, if you want to play around with SaaS, we have a reference implementation with serverless technologies. It's available in GitHub, free to use. You have to pay your AWS bill though. That's not free. We are also making something called SaaS Builder Toolkit or SBD. That's brand new. It's still under active development. So this will give you the tool set in the form of CDK construct to build SaaS, maintaining all of the best practices that we know of so far. Okay. That's it I have for today. Thank you.
Do you have time for questions or not?
You have time for questions?
Is
We
there
can
any-
do a few questions.
Yeah, my flight leaves in 2 hours. That's fine. You can reach out to me if you have any questions or you are shy to ask now. I won't charge anything for emails.
Yeah, we can do definitely a couple of questions.
Yeah.
Sure.
Any questions?
I have one question. So I was just thinking about that, the partition of the queue. So instead of putting different channels in one queue, so can we just if we see that the queue is very long, we just chop the queue and then just put it.
Yeah, that's essentially what we did. We chopped the queue and
Yeah.
distribute different.
I mean that so we don't need to have the tenant mapping, and we don't need to have that rebalancer. We just make the queue shorter so that even though that there are other tenants that their message there, but if the queue is very short, and then it can quickly execute their message. So
Okay, I think the picture was a bit deceiving. So we cannot make queue short or long, really.
I mean just create our rework. So if we saw that a lot of messages, and we just create a new queue and then put the things there.
That's essentially what the rebalance.
Yeah, that's essentially what the rebalancer would do. Yes, you don't have to. You can.
So you need something.
You-
that's
So in that case, you need to have a fixed logic. Like I can only have 3 queues. So first message would go there, second here, third here, and then it repeats again. But having a mapping can help you decide that dynamically. Like, okay, only tenant 1 would go to Q1, tenant 2 to 10 would go to Q2, and after that, all the tenant would go to tenant 3. You cannot do that with a hard-coded logic. Yes.
So if you don't have that mapping, then you can't really guarantee that the third tenant message is going to be processed in order. So if you have
There-
a process requirement that messages from a tenant get processed in the order in which they were put in the queue.
But that would be FIFO, right? Without FIFO, you can directly.
So I don't think there would be a business need to guarantee that. Like
Yeah.
messages coming in would have to be processed exactly in order.
per tenant.
Yeah.
Yeah, cross tenants obviously you would kind of.
I guess that's fair.
But otherwise you could just use Kinesis or something, right? You could just-
You can, but that would be more for event processing, right? Because message processing would give you some other benefits like failed retries, visibility timeouts. What would happen if you cannot process a particular message, like the dead letter queues or DL queues, those sort of things you have to manually build on top of Kinesis. Yes.
The patterns that you or your team discovers, does that comes from AWS? Because AWS itself is a SaaS, right?
I work in AWS, yes.
Right. So my question is like, do you guys extract those ideas from there, or like
No.
you guys build out? You guys don't go
No,
over there?
no, it's building SaaS on AWS, man. You're missing the last word, AWS.
No, I know, but in a sense, if you look at it, if in a noisy neighbor situation, right? AWS might have a noisy neighbor situation. Like one of the customer at a availability zone is noisy. So you guys are protecting that or throttling that somehow, right? So that's what I'm saying. So those ideas are can be abstracted from whatever AWS team internally have done, right?
Yeah, so those situation is normally network related, and that's way above my pay grade.
I can cover it, so I heard the network for it, so I can cover some of those. I have a private screen.
Yeah, so I can tell you I've attended one of the advanced networking session. I thought, what's there to learn? I know a lot about network, almost all. But then I attended the session and I understood like barely 1 minute of it, and then I left. They work in a different level.
Yeah, there's a reinvent. There's a reinvent.
Yeah. If you're interested, go into that, see how they encrypt and maintain security and make sure that you're not congested. Very interesting. Yes.
I was going to say, you probably forgot you're at a serverless meetup, and just with the queues, I mean, couldn't you just stick a Lambda with 3,000 concurrency on that? You're not going to worry about messages not being processed.
But it would still be processing 3,000 messages from one single tenant. The idea here is that one tenant has 3,000 messages and one has one. You should give them the same priority. That you process one message for tenant one, and the second message should be for tenant two. Not after 3,000 more messages.
Yeah, well, I mean, 2 seconds. Yeah,
It's a scale problem.
yeah, that's a pretty.
And
Yeah,
that goes
maybe
back
you've got a
to,
massive scale. Yeah.
that goes back to the other question about when you
Yes.
you need to start basic. And then as you
Yeah, I mean, if you've
customers,
got
when you have
multiple
problems
queues,
solved.
then one's
Exactly.
3,000,
So
the other one's gonna have
you don't
3,000,
start.
6,000.
Yeah. So the idea is you don't start with the full-fledged implementation. You start with the idea that I might go into that. It's a good problem to have. That means you have a lot of customers who's putting load. You're earning a lot of money. Now you can invest into building something complex. You don't start with the complex thing, but you have it in the back of your mind. I can support in those situations. That's the whole point of this presentation. All right. Thank you.
So much.
There's some pizza back in